In this video, we're going to look at differential equations which occur in regular A-level. So in regular A-level, you'll only ever be asked first order differential equations, which involves a technique called separating the variables. So here we've got 1 plus x squared dy by dx equals x times tan y. So we're going to get all the x terms on one side and all the y terms on one side. So I'm going to get 1 over tan y equals to x over 1 plus x squared dx. Now we're going to integrate both sides here like so, and 1 over tan is the same thing as cot y. So we get the integral of cot y, should be a dy here, so dy is equal to the integral of x times 1 plus x squared dx. So I'm going to start off with the right hand side, which is the integral of x over 1 plus x squared, because you should have already done this in regular A-level in integration by substitution. Why is it integration by substitution? You've got a function 1 plus x squared and its corresponding derivative in the same function. Therefore, we must use integration by substitution. So we're going to say let u be 1 plus x squared du by dx is 2x. Let's improve the clarity of my handwriting there. So that's 2x. Then we're going to say du is 2x times dx. So a half du is equal to x dx. So that means my integral now becomes the integral of, take the half on the outside as a constant, du. Now 1 plus x squared is u, so we could write that as a half integral 1 over u du, which is a half ln mod u plus an arbitrary constant c. Now we can replace u with 1 plus x squared, so it's a half ln bracket 1 plus x squared in mods sine plus c. So now you should know from regular A-level that the integral of cot y is ln sine y. So that's going to be, I'm going to write that here, the integral of cot y dy is ln sine y. Now what we have is we have ln mod sine y is equal to half ln 1 plus x squared. Now this c can be replaced with in a function in form of ln because it's a constant. So I'm going to write that as ln k, a constant in terms of ln. So we do that because we can manipulate the laws of logs. So we can say that what we have here is ln sine y is equal to ln in brackets 1 plus x squared raised to the power of a half plus ln k. Now from the laws of logs, we can actually say that when we add logs, we multiply them. So it's ln sine y equals ln k times 1 plus x squared raised to the power of a half. And now what we can do is anti-log both sides, or take exponents to both sides, mean the same thing. So therefore sine y equals k times 1 plus x squared raised to the power of a half is our solution. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we can separate the x and y variables here by doing 1 over y squared dy is equal to sine squared x over cos squared x dx, and we're going to integrate both sides. So we're going to rewrite this as the integral of y to the power minus 2 dy equals the integral of tan squared x dx. So from regular A level, you should know how to integrate tan squared x dx. We need to use the trig identity, that sec squared x is identical to 1 plus tan squared x. So sec squared x minus 1 is equal to tan squared x. So I'm going to replace that the integral of tan squared x dx is identical to sec squared x minus 1 dx. So these are all integratable functions now. Sec squared x integrated is tan x, and 1 integrated is simply x. So let's integrate y to the power minus 2 dy. That simply gives me y to the power minus 1 over minus 1. We don't need to worry about the arbitrary constant, we've already got that. So that's going to be minus y raised to the power minus 1, or in other words, minus 1 over y. So we could write this as minus 1 over y is equal to tan x minus x plus the arbitrary constant. So we're going to take all of this, bring it down here, take the y, move it up. So what we end up with is therefore y equals to minus 1 over tan x minus x plus the arbitrary constant c. Now the next type involves again separating differential equations by separating variables, but it's going to involve a partial fraction. So let's first of all separate them. And minus 2 equals to minus 3 over 2x plus 1 times x plus 2. Now what we're going to do here is to use partial fractions. So we're going to say that minus 3 over 2x plus 1 times x plus 2 is the same as a times 2x plus 1 plus b times x plus 2. So from partial fractions, we know that we're going to times this one by x plus 2, times that by x plus 2, times that by 2x plus 1, times that by 2x plus 1. So now we can say that minus 3 is a times x plus 2 plus b times 2x plus 1. And in partial fractions, we want to make either one bracket equal to 0, then solve for the other. So I'm going to solve for a first. I'm going to say let 2x plus 1 equal 0. And solve for the value of x we need. So what value of x makes that 0? So that's going to be minus a half. So x equals minus a half. So this is the value we're going to substitute in. So we're going to say sub x equals to minus a half, right? So we get minus 3 is a times minus a half plus 2, which is the same thing as 1.5. So we get minus 3 is 1.5 times a. So it's minus 3 is 3 over 2a. So that's going to give me as follows. Minus 3 divided by 3 over 2 is a. So a is minus 3 over 1 divided by 3 over 2, which is going to be a is minus 3 over 1 times 2 over 3. So we can say they cancel out here. So a must be minus 2. So now we need to make the other bracket equal to 0. So we can make, to make a 0, we're going to let x equal to minus 2. So to get minus 3 is b bracket 2 times minus 2 plus 1. So minus 3 is b times minus 4 plus 1. So minus 3 equals to minus 3b. So b equals to positive 1. So what that means is we could rewrite our partial fraction as the value of a, which is minus 2, and the value of b, which is positive 1. So we're going to get minus 2 over the first part, which is 2x plus 1, and then plus 1 over the other fraction, which is x plus 2. Now that we've got that, we can then go ahead with the integration. So what we want to do essentially is to now add in the dy's and dx's. So this is a dy here, and this is a dx here, and now we're going to integrate these. So let's do the partial fraction one first. So that's going to be the same thing as that integrated. So it's the integral of minus 2 over 2x plus 1 plus 1 over x plus 2 dx. Now that gives me, so here for this integration it's going to be minus 2 ln mod 2x plus 1 divided by the differentiation of 2x plus 1 from the chain rule, and then we're going to get plus mod ln mod x plus 2 plus c, right? Then here this is going to give me minus 2 over 2 ln 2x plus 1 as a mod plus ln x plus 2, the modulus sign, and we're going to change c to ln k. So that gives me minus ln mod 2x plus 1 plus ln mod x plus 2 plus ln k. So we can use the laws of logs here, so we can say that minus ln mod 2x plus 1 is the same as ln. When you add logs, you can times them, so you get mod k times x plus 2, and then there should have been an equal sign here. We've got a plus sign here. So then we can divide them because we've got a minus here, so it's the same thing as ln mod k times x plus 2 over 2x plus 1. I'll just reiterate that again. Because of the minus sign, we can divide the logs from the laws of logs. So that's what we get there. Now, don't forget that we had originally 1 over y minus 2 dy. So we need to integrate that. So the integral of 1 over y minus 2 dy, that's going to be ln mod y minus 2. So now we can rewrite our equation as ln mod y minus 2 is equal to what we just found above. So that's going to be ln k times x plus 2 over 2x plus 1. Now we are going to anti-log both sides. So the e and the ln cancel. And what we end up with is y minus 2 is k times x plus 2 over 2x plus 1. So now we are going to substitute the limits in, or the boundary conditions rather. So we get 4 minus 2 equals to k times 1 plus 2 over 2 times 1 plus 1. So we get 2 equals to 3k over 3. So that's over 3. So we get 6 equals to 3k and k equals 2. So now that you've got the value of k, they want the form of y equals fx. So now we're going to rewrite our function y minus 2 equals to what we found. K was 2, so it's 2 times x plus 2 over 2x plus 1. Now, the book doesn't really explain this clearly, but it should be y minus 2. Expand the brackets here. We're going to get 2x plus 4 over 2x plus 1. So we're going to sort this out or tie this up. So it's going to be 2 over 1 plus, when you bring the 2 over, 2x plus 4 over 2x plus 1. And then we're going to times this by 2x plus 1. And times this by 2x plus 1. So let's make this a bit more neater. So this is going to now be over 2x plus 1. So we get 4x plus 2 plus 2x plus 4 over 2x plus 1. So now we get 6x plus 6 over 2x plus 1. So what I'm going to do here is do an algebraic division. So I'm going to do 2x plus 1 divided by 6x plus 6. And we're going to get a 3 here. And then 2x times 3 is 6x. And 1 times 3 is 3. We're going to minus these now. And I get a 3 remainder. That's why in the book you get that solution. So we can say that 6x plus 6 over 2x plus 1 is exactly the same as the quotient being 3, the remainder being 3 over 2x plus 1. So therefore, our function is Therefore y is 3 and 3 over 2x plus 1. Here's a question for you to try. You can pause the video. When you're done, I will go through my work solution. Okay, welcome back. So it's a question I've chosen which is involved partial fractions. So apologies that this video is quite long, longer than normal, but the steps are quite involved. So we are going to write this as follows. We're going to write this as 1 over y dy is equal to 8x minus 18 all over x minus 2 3x minus 8 and with a dx on the numerator. And I'm just going to write the integral signs here in pink like this. So before we do any kind of integration, we need to sort out the partial fraction. So we're going to write this as follows. We're going to write this as 8x minus 18 all over x minus 2 times 3x minus 8 is the same as a times x minus 2 plus b times 3x minus 8. So from partial fractions we can say that 8x minus 18 is a times 3x minus 8 plus b times x minus 2. So we want the b term to go to 0, so we're going to say let x equals 2. So we get 8 times 2 minus 18. B's gone to 0, so we get a. 3 times 2 is 6. 6 minus 8. So that gives me minus 2 equals to minus 2a. Therefore a is 1. And we want to make 3x minus 8 equals 0, as I showed in the previous example. So we can say x is going to be 8 over 3. So we're going to substitute that in. So we're going to say let x equals 8 over 3. So we're going to get 8 times 8 over 3 minus 18 is b times 8 over 3 minus 2. So let's use our calculator here. So 8 times 8 over 3 minus 18, which gives me 10 over 3. And let's do the same thing here. 8 over 3 minus 2. I get 2/3 of b. 3's cancel out, so I get 10 equals 2b. So I get b equals to 5. So now my partial fraction is going to be 1, or the value of a over x minus 2, in our case is 1. So it's going to be 1 over x minus 2. Now b, we've got to be positive 5, so it's plus 5 over 3x minus 8. So now what we want to do is to integrate this. So I'm going to put an integral sign here, put some brackets, put a dx. So what we get is ln mod x minus 2 plus 5 times ln mod 3x minus 8 divided by the differentiation of that. I'm going to write it in full, plus c. Now, what we have is the following. So we get ln mod x minus 2 plus 5, and then we get over 3 ln mod 3x minus 8 plus c. Now, we've got some boundary conditions, so we need to substitute that in. So x equals 3 and y equals 8. So don't forget, we also need to integrate 1 over y. So I'm going to write that in. So the integral of 1 over y dy is simply ln mod y. So ln mod y is equal to all of what we have here. ln x minus 2 plus 5 over 3 ln mod 3x minus 8 plus c. Now, they've told us in this question that x equals 3 and y equals 8, so let's do a substitution. So we're going to say that when we have these values, we can work out what this is. So in order to do that, we need to work out what c is. So we're going to say ln 8 ln, now we said that x was 3 in our case, so it's going to be, well, I'm going to write this as 3 minus 2 just for completeness, plus 5 over 3 ln, well, 3 times 3 minus 8. So we get some nice values here. Well, ln1 is 0, so I'm going to write this out in full. So I get ln1 plus 5 over 3, or 9 take away 8 is 1, so we get ln1 again, plus c. So what happens is we get that ln8 is 0 plus 0 plus c, hence c is ln8. So we want to write our function in the form of y equals fx. So we can write that as follows. We could write this as, we're going to write as ln y so ln mod y is equal to ln five over 3 ln, so then what we're going to do is write this as ln y equals ln x minus 2 don't forget the mod sign, plus 5 over 3 ln 3x minus 8. But we also know that c is now ln 8. So what we can do here is manipulate the laws of logs. So we could write that as ln mod y is equal to ln. Now we could write this as follows. We could write x minus 2 plus ln mod 3x minus 8 raised to the power 5 over 3. And we got also an ln 8 term. So now what we have is, from the laws of logs, we can multiply them together because they're all additions. So it's ln mod x minus 2 times 3x minus 8 raised to the power of 5 over 3. And I'm going to put the 8 over here as well. So put the 8 in front of it. And we've got an ln here. And that's what we get. Now, what we can do is we are going to then use antilog. So we can antilog that. So that will give me, let's antilog that here. So we get therefore y is, or they will cancel out. They will cancel out. Y is 8x minus 2, 3x minus 8 raised to the power 5 over 2, 5 over 3, excuse me. That's the answer.